Let's talk about how we find the surface area of a cylinder. And just as a reminder, surface area means how much material would it take to cover the outside, like if you were going to paint it or cover it with wrapping paper, something like that. How much material would that be? Volume is how much would it take to fill it up. So if you were pouring water into this, that would be the volume. Surface area is just how much material do you need to cover the outsides. So first thing I want to point out here is we've got kind of three things we need to do. Two of them are the same. We've got a circle that's the base and the top of our shape. So the area of a circle is pi times the radius squared, and we have two of those. They're going to be the same in a cylinder, so we just need to say, well, we got two circles. 2 times pi times radius squared. Now, this next part, this kind of what we call the lateral area, this piece in here that we would need, here's how I would think about that. So imagine if you had a rectangle like this, like a piece of paper, and then you just took that rectangle and curled it around. Well, then this would be your lateral area of your circle. So what we need to do is we need to figure out base times height. And the base of our rectangle is simply the circumference of our circle. So we're going to use the circumference formula to figure out the top, and then the height we will be given. So as a reminder, the circumference formula is 2 times pi times the radius. So that serves the base of our rectangle that gets kind of folded around and then multiplied by the height. We simply add those pieces together. So as I said, we're adding kind of three surfaces. We have two circles that make up the top and the bottom, and then we have the rectangle. Base is the circumference, and then height that makes up that what we call lateral area. Let's do an example. So let's say we have our cylinder with these dimensions. So we have our bases, our base and our top, I guess. 2 times pi times the radius squared. Again, what that's giving us, this part and this part. And then we're going to add that lateral area, 2 times pi times the radius times the height. And we'll type all of that into our calculator. If you have a calculator that doesn't have a pi button, you can substitute like 3.14 in for pi. It's a nice estimate, gives us a fair amount of accuracy. It's not pi, but it gives us a nice amount of accuracy. All right, so you can see I typed it in. Again, I have a pi button. If you don't, just use a 3.14 as a nice estimate. 2 times pi times the radius squared plus 2 times pi times the radius times the height. And there's our answer, 471.2. Let's do one more example. Okay, now this time I've given you the height, but I've given you the diameter. So please remember, we always want to have a function of the radius, so I would just cut that diameter in half. So then we can say it's 2 times pi times my radius squared plus 2 times pi times my radius times my height. I should also mention, besides telling you that you can always substitute 3.14 in for pi, if you have a calculator that doesn't have a square button, you can always just instead of writing 6 squared, you could just write 6 times 6, because that is 6 squared. Let me show you what that would look like. So here's what that might look like if you didn't have a calculator that had a pi button or a square button. So I did 2 times my estimate of pi times the radius squared. I just typed 6 times 6 plus, and then 2 times, again, my estimate of pi times the radius times the height. If this video helped you, please like and subscribe for more geometry help.